Good day and welcome back to Maths and Physics with Mr. Simons, where we make maths and physics simple and get you exam ready. Right. This Euclidean Geometry lesson we're doing today, we're solving problems using Theorem 1, Theorem of Pythagoras, and specifically Midpoint Theorem. So we teach the Midpoint Theorem in grade 10, right? And then we don't read to it in grade 11 and 12, but we can still use it to surprise you in a grade 12 exam paper and sometimes even a grade 11 exam paper. So I hope you follow carefully in this problem. This is much just to get you ready for exams and make sure you remember to practice the midpoint theorem, which you know. So given O is the center of the circle, AB equal PC, MC is the diameter of the circle. That is what's given to us. Right, so I didn't type out the questions, I'm just showing you what is given to us. So if O is the center of the circle, I assume you know that MO equal OC. So on the one side I have two sides that are equal, and then on the other side I have two sides that are equal. So automatically this brings in, I know grade 12 you do proportionality theorem, for grade 11s you haven't done proportionality theorem. So automatically it brings in what we refer to as the midpoint theorem. That states that if MO equal OC and AB equal BC, then automatically OB is then parallel to MA and OB equal half of MA. That is the midpoint theorem. So make sure you go practice and remember it. Alright, don't come into exam and be short by not studying certain things that's important, and then we catch you out with those simple things. Prepare fully. Right, so question 1. Can you prove that angle A equal 90 degrees? Right, now take note, I know there's a simpler way by using theorem 3, but here I'm just working on the basis that I only know theorem 1 and theorem 1 only. Right, so MO equal OC, it's a radii. AB equal BC, that was given. So automatically then MA is perpendicular, or not perpendicular, MA is parallel to OB. Right, and my reason would be midpoint theorem. Right, but O is the center, so OB is a line from the center, and that line from the center cut according to two equal halves. So therefore, it must subtend, according to theorem 1, an angle of 90 degrees. So I can say that OBC is 90 degrees there. My reason would be midpoint chord, theorem 1. Right? But because this line is parallel to that there, I assume you can see they have 90. That one would also be 90, and my reason would then be corresponding angles. Right, so A equal to 90 degrees because MA is corresponding to OB. Right, once you've learned theorem 3, you'd have just stated because MC is 90, is the diameter, it subtends a 90 degree, according to theorem 3, angle in a semicircle. Right, but there I hope you follow what I've done. Let's look at the next question. Prove that MA, so this line MA equal 2 times OB. So we already know that MO equal OC and AB equal BC. Therefore, we proved in the previous problem MA is parallel to OB. And according to midpoint theorem from grade 10, then automatically MA is 2 times the measure of OB. So it's 2 times the size of OB. So MA equal 2OB according to the midpoint theorem. Right, let's go to the next problem. Prove that AMO, so let's see, AMO, this angle here, is equal to BOC. So from B to O to C. Right, so there we've already proven that these two lines are parallel and we had corresponding. So you can see this angle they've asked for, and that angle there is also corresponding. So in short, AMO equal to BOC, they are corresponding angles. And my reason, MA is parallel to OB. So generally, if you look carefully, if I draw on that parallel line and that one, and I join them up, it forms the letter F. Right? go to the last problem. Now, can you prove that AOC from AO to C, this whole angle here, equal 2 times CMA? So CMA, so that whole angle there is 2 times the size of this angle here. So in short, that is the angle at the center, and that is the angle at the circumference. So first I'm going to start off and I'm going to draw AO so that I can form that angle properly. Alright, so now I know AB equal PC, it's given. Alright, so therefore automatically if this is equal to that, right, that means I have ABO and OB or CBO both equal to 90 degrees. So that's 90 and 90. It was proven in question 1. PO equal PO, it's a common side. So therefore AOB is congruent. AOB is congruent to COB, and my reason side, angle side. Therefore AOB, so AOB there, and COB must be equal. Right? They are congruent triangles. Right? But CMA, that angle there, equal COB. Right? And my reason, congruent or not congruent triangles, that was proven in question 3. So CMA, that angle there, equal POC, they were corresponding, equal AOC. Alright? And AOC equal AOB plus POC. So this angle AOC equal the 2 added together. Right? So if the 2 of them added together then equals that angle, then I can say AOC equal 2 times, no, I typed this back to front, my apologies. It should read CMA, AOC equal 2 CMA. So CMA there was the size of this angle here, but that angle is the size of all the other angles. So this whole angle added together equal 2 times that size. So this one is the size of that, but this angle equal the size of that angle. So those 2 added together is twice the size of that one. Right? And that is technically theorem 2, which we're going to go to. So AOC then equal 2 CMA, and the theorem 2, which we will get to, we would have said angle at center equal 2 times angle at circumference. Right, so I hope you follow, I hope you understand. God bless. Bye.